Welcome to Rubber Duck Engineering. Tonight, we're going to talk about solving Freecell games or finding unsolvable Freecell games or other edge casey kind of things. Welcome.
Hey,
Happy
Eric, how you
Wednesday.
doing? Eric messaged me in the middle of the day today. He was like, "I'm really interested in edge cases." I was like, "All right, let's go find some edge cases in Freecell."
Yes. Well, there was some Hacker News article. I think it was in that I think was about this, and I really enjoy. It's part of the whole like building game simulations to like learn something about the game once from the simulation, and it's interesting to me the idea of like what percentage of Freecell games are unsolvable, or what does it take to cause a Freecell game to be unsolvable. Freecell is like a little too big to like fit in my brain. It's not like chess or Go size, but it's like I don't know what 52 cards and lots of orders, whatever, what 52 factorial or whatever. Because I think the whole thing is based on the deck order, right? And
Yeah, you sort of deal it out, but there's no hidden information. You deal out the whole table at the beginning, and then you get to see everything.
but the whole game is specified by the original deck order, right?
Yeah, so like in the original, I don't know if it was the original, but the one that popularized it on Windows, you just type in a number, which is the seed for the deck order, and then that just deals out all the cards, and then from there the game is fully determined.
I've never looked up, this is somewhat of an aside, but I'm so curious. I've never looked up how they map between deck orders and seeds and how they make
good news. The seed project that we're starting, different kind of seed, the primordial project that we're starting from has that algorithm in it. So we can go take a look at it.
What an excellent transition. I will add the code machine. So show me this, because I actually, again, I'm taking us off on a left field, but I'm actually really interested. Like, does it repeat? Are there some seeds that map to the same?
Maybe how. That is a good question. I think we can try to figure that out. So just to give credit where credit is due, we cloned a GitHub repository into just a blank C++ replit.
Yep.
So this repository is from I'm not sure how to pronounce the person's
Totally
name.
blank. Yeah, I don't know who this individual is. Freecell server. Yeah. You were gonna say?
We'll put a link in the comments.
Oh, it's right here, right? Macro.
Yes, that's the person.
Macro
UXE.
Yeah. UEA. Mm-hmm.
Okay. So if you go look in the solver directory is where this person has their solver. And the particular thing, I looked at the code a little bit before the show. So if you go look in the node.cc file, there is a function called, actually it's in node.h. It's called, if you look at the constructor, so you pass in the deal number, and then right there on lines 53, starting on line 53 is how it randomizes it.
I see. So I suspect from this, there definitely are multiple seeds that point to the same deal.
Yeah, just to talk through it. So it's basically, it lays out all the cards in order and then uses this very particular random number, pseudo-random number generator that was in Windows. And then it swaps the cards based on the output of the random number generator. And so clearly if it's swapped it one way and then swapped it back, you get the same deal. But I think that may just be unlikely. And since they only go up to 1 billion seeds, they may not be enough to repeat.
Well, it makes me now want to ask the question, which would be easy to write based on the source base. What percentage are repeated? And what's the coverage look like in terms of like the total deal space? How presumably it's even coverage if the random number generator was random enough. Anyways, we don't need to answer those now. These are things that pop into my head.
Yeah, it looks like it's shuffling enough to get a pretty random sample. Like it's doing a number of swaps equal to the number of cards, which seems like it gives each card a chance to be in any position.
Okay.
Do you want to try just running the solver just so people can see what the starting point is? If you go over to the shell, I've already compiled it.
Here?
No, the shell tab over to the right.
Okay.
Yep. And if you just cd into the, I think maybe I can do it too.
Whoa, we have like a whole VM here?
Yep.
Okay.
I'll go into solver.
It's nice that they put it in, whoever designed this split out the solver.
Yep. And then if you just say /solver, that'll run it.
Whoa.
Oh, we should say hi to folks. Hi, Hashim. Thanks for coming by. Hi, Hal. Thanks for coming by. Static, thanks for joining us. We're doing great. Hope you're doing well too. Anyway, so you run it. It has a sort of nice graphical, pseudo-graphical visualization, and then goes and solves it and gives you the answer.
Somebody spent some significant amount of time on this little project here.
Yeah.
And when I was searching for images, there are a lot of these Freecell solvers and such.
I think it's a fun thing. Like, it's a very popular game, and so the solver, like, it's a not trivial program, but it's also not like a huge amount of work. Like, it's a thing that a single person could do given some time and attention.
Mm-hmm. That makes sense. So what is this? This is the deal? I see. This is the dealing them out into 8.
Yeah, so I think that if you like, those are the columns of the Freecell, so they have all the different cards in slots 1 through 8, and then there's starts out with no cards up at top, and then empty foundations. Then you basically move the cards around and build up on the foundation.
And do you know what this is telling us?
I don't know what that is telling us. We can fire read the code and find out. I believe the one at the bottom is the actual solution. Like, those are all the steps that you take.
1:4.
I'm not sure how to read this chart.
I mean, I'm sort of taking us off into the wilderness here, but it's fun to like read people's code. At least I find it fun. All right, let's see. What are we doing? Set cards. Read solution. Beams? What the heck's a beam?
I'm not entirely sure what a beam is.
I wonder what sort of jump to definition.
The beam is defined in this file just a little bit higher up. We're trying to figure out what it is.
Whoa, start thread? Like if I'm commenting on this. Whoa, today I learned Replit has comments on the code. That's kind of cool.
Yeah, I think it's using I think it's using multiple threads to try to figure out.
Oh no, this is like a comment thread. I mean, this other thing may be threaded too. A standard bind. Yeah, okay, you're right. It is using threads. Whoa. Maybe a beam is like for searching. Like it's
I think
based on this seed, based on this size. It gives it some identifier and like the total number of splits. So it's some split of the search space, presumably. Anyway, this is all something. I've taken us kind of left field here. Prefix.
Yeah, so I think if we wanted to find an impossible Freecell, the way I imagine doing it is different Freecell boards will take a different number of moves to solve.
Okay.
And I imagine that you're getting closer to an impossible board the more number of moves it takes to solve the board. And so we find some way of searching or exploring the space of boards in a way that keeps increasing the number of moves it takes to solve it, that will eventually get to an unsolvable one.
So I do have some concerns about sort of doing this blindly. As we saw here in this solver, like this random deal took several seconds.
I think it's trying to find the optimal path. So I think when it says upper bound, I think that means it just found a solution that took 128 moves. Maybe we should try to figure out what it means by upper bound, or what this number that it's printing out is.
I was thinking this was maybe the number of solutions it was trying. Because it seems by some but yeah, we should. Upper bound.
Yeah, you're just searching for the next upper bound. Isn't it?
Max moves plus 1. The solution is produced by this beam. Send it to other beams to to lower their upper bounds.
Yeah, I think it's trying to search for the optimal solution. But I mean,
Okay.
maybe that's fine too. The thing I was more worried about is because it identifies deals with these random seeds,
Mm-hmm.
it's going to be hard to explore the space by finding like deals. Because if you just change one bit of your random seed, you've got a totally random other board. You'll be exploring the space
And
in a
there's no
random
way to
order.
move from deal back to random ID or whatever.
Yeah, I'm less worried about that. Like I'm more thinking we want to input to the solver that is in some in some way will make it easiest to move from one board to a similar board to see whether, hey, does this make it harder to solve or just make it easier to solve?
Staying in brainstorming land for just a moment here. There's another way we could approach this, which you and I were talking about a little bit in the green room, that we could look at this by making the problem smaller. Like this problem doesn't fit in my head, and like enough that I don't even quite know how I'd think about writing a Freecell solver. And I'm sure I could, plunk my way through it, but like, um, I just wonder what like a minimum version of Freecell that has an unsolvable board looks like. Like if you had, like say your deck only had one card in each suit, but still had 4 suits, so you only had 4 cards in the deck. There are no unsolvable boards there.
Right. Regardless of the number of columns.
Correct. Regardless of the number of columns.
Mm-hmm.
Right. But if you have one column, one suit, and 2 cards, there is one unsolvable board and there's one solvable board.
Right.
Right?
So, yeah. So if the ace is on top, then it's solvable. And if the 2 is on top, it's unsolvable.
And so it's some sort of ordering thing. But then I haven't sat down to reason about like, okay, so if you have 2 suits and 2 cards in each, and one column I can easily think about, right? It's only if there's within. So then 2 columns.
So just complete your thought. It's just as long as the aces for a given suit are before the 2s for that suit, then it's okay.
Yeah, both suits have to be in order within a single column.
But the intermix between the 2 suits doesn't matter.
But the intermix, correct. Yeah, if either suit has its ace out of order and you have a single column, you are unsolvable.
Mm-hmm.
But if you have 2 columns, then I actually don't know.
It's definitely unsolvable if both the 2s are on top.
But so that would be the only one.
If one of the aces is on top, then yeah. So if it's like red ace, black 2.
Mm-hmm. This is where we need
red 2, black ace.
This is where we need like a card simulator or something to like show. But I'm like this just like reminds me back of my whatever combinatorics class or my math classes. But yeah, if it's going to be 2, like if we think about the columns as rows instead, and the 2 ace, 2 ace, I guess this is the top. That's unsolvable. 2 ace, ace 2.
Also unsolvable.
Oh, why? Because you can always pull.
I guess it depends what color it is. If the top ones are both red, then it's unsolvable. And the bottom ones are all black.
Oh, if these are both red,
that is solvable. Yep.
That's definitely solvable. But 2. So show me one that's unsolvable.
I mean, it's just it's like it reduces to the previous case, right? So if you have 2 red, ace red, oops, and it doesn't matter what you put here, right? Ace black, 2 black, and these will go up to the tableau, but this one will still not be solvable.
I'm sorry.
Oh, I guess, sorry, we're assuming that the number of free spaces is also 0. So once you have free spaces, then the equation changes.
Well, if you have 2 columns, as soon as you, so I'm sorry, you play.
Oh, I see.
Base
You play
flag
those
goes up.
2. Yeah, these 2 go up, and then you move this over to here,
Correct.
and then it goes up.
And so it's that free spaces and the number of columns. There's some sort of interaction going on here.
Mhm.
I'm sure somebody's written a mathematical proof. There's a place, maybe it's in the reserve, where cards can be removed from the capital without going to foundation.
There's a place, maybe it's in the reserve, where cards can be. Yes, that's. I think this calls the reserve, the solver. So, right. So we're currently assuming that there's 2 columns and no places in the reserve. So no.
How many decks are there in this? Is it? It's like 2 pick. It's 2. I don't remember my combinatorics. It's 2 pick 2 times 2 pick 2. Do you remember combinatorics?
I would do it from permutations. I'd say it's 4 factorial, and then divided by the symmetries. So the symmetries are going to be just the swaps of the 2 columns. So it's 4 factorial divided by 2.
Well, you can just think of it as deck orders, right? 4 factorial divided by 2. And 4 factorial is 4 times 3, 3 times 2. So that's 12. So there's 12 decks. And I posit that there's only one. No, these are presumably. This is really hard without more visual aids. I would need to get out colored pencils. This is unsolvable. Oh, I think I copied this and I was trying to answer whether this was solvable, right? Is that? And that's unsolvable. And I guess there's 2 other swaps of these. Right, these swapped are also unsolvable. So there's 4 of 12 that are unsolvable.
But as soon as you introduce one of the reserve spots, then they're all solvable.
What do you mean a reserve spot?
So when you're playing Freecell, you can move the cards around on the tableau, but you also have these 4 empty spaces that you can temporarily put cards in.
Oh, yeah, I may be thinking of Klondike. We haven't defined our terms. We would not be doing a good interview problem here if we haven't. I think it was the last episode you were talking about how you failed your PM interview because
Yeah, exactly.
The vending machine was for a giraffe, right? We haven't agreed on what our actual problem we're solving is here.
Okay, so I think we should pick a strategy. Are we going to pick a strategy where we use knowledge of Freecell and we build up from simpler things, or are we going to try to treat Freecell as a black box and try to get the solver to tell us the answer without us having much knowledge of Freecell?
My default would be to go this way, but I think we lack the tools in terms of we lack good. Again, I think you use colored pencils and a piece of paper. At least that's how I would have done it back in whatever it was, 2000 or whatever, when I was in my last math class. So I think we may just need to stab at the code because we have a good code tool.
Okay. So do you want to pick a strategy? So I think the most useful thing for stabbing at the code would be to understand what these numbers that it's printing out mean.
Okay.
Because I'm kind of hoping one of the numbers is how some measure of difficulty of the board.
Oh, I suspect that these are number of attempts.
I don't know if you just find out.
But this is going to end up being a reading code episode, but that's fine. What's this encode solution thing? Is this a seed coded solution? No.
Okay, this is clearly what it's printing out, right? Oh no, this is the last thing it prints out here on solver.cc on line 313. This is the thing it's printing out at the end. Is here is the solution that I found. So here's what
it's prints out levels size. Right?
Levels and size. Okay, what does that mean?
I don't know what levels is. Beam search. I saw someone tweeting today. I deleted Twitter last week, but I still have been guiltily loading up twitter.com in my browser. I saw someone tweeting today the love of the detailed documentation on like the inner deep functions of Flutter, which I'm sure is the culture that you started. And they were just like, oh, nobody does this. All this like inner gunk is documented.
You gotta write it down, otherwise no one knows how it works.
Yeah, you gotta write it down because otherwise I don't remember next week, let alone someone else.
So I'm reading this solve function here. So it looks like it just initializes this move vector to be empty, and then calls this prefix search function, which looks like it just prints out this. So I bet max moves is 128. Look at this constant. Then what it does is it plays some moves, prints things out. If it found a solution, then it's solved, and it encodes the moves. So maybe this string that it prints out at the end, this length of this string is the thing we should try to maximize.
Oh, this thing? That's only when it has a solution.
Mm-hmm. Yeah, so I think if we keep making that string, we find boards that keep making that string longer and longer, eventually it'll give up and say, I don't know how to solve this thing.
But you suggested we have no way to move from one board to an adjacent board.
Right, so I think that's the thing we need to figure out how to do, is we need to change the input to the tool to be something more malleable that we can then explore from.
Instead of this seed, right?
Mm-hmm. Like what if we just took a board layout and we just swapped 2 of the cards, and then we fed it into the machine and said, did that make it easier or harder to solve?
Right.
And then you try 10 of them, and then maybe you pick the one that was the hardest, and you just keep exploring from there and seeing if you can find an impossible board.
All right, we're going to end up with a refactoring problem is what we're going to end up with.
Mm-hmm.
But that's okay. Let's see, what is this? Just seed options. Where do we use our options? The beam must take the options, right? No?
Yeah, so you look here on line 342. This is where it sets the layout of the cards. So I think we need some other input option that will let us set whatever layout for the cards we want.
That's what this node is, right?
Yeah, the node seems to represent a particular configuration of the cards.
Okay, so let's see what node I see. So this is node from deal number.
Mm-hmm. So in node.h, I think we should make a new constructor that will allow us to construct it with a without the deal number, with something else.
Okay. What would be a different encoding?
Like a different encoding might be just if we just list out the swaps that we want.
Mm-hmm.
So we'll just start with the cards dealt out in order as our starting point for exploring the space, and then we'll send it. We'll just give it numbers that say swap this position and that position, swap that position and that position.
And so it's like, okay, so then you could basically do it as a string, right? And the string is then a list of indices, right? You treat the characters, it's a byte buffer, but you can use a string for it. And each one is you need pairs, right? To do swaps.
Yeah, so I'm imagining there's 52 positions. And so we would probably need like upper and lowercase letters. Mm-hmm. And then we can give two letters to indicate the swap that we want.
Okay. And are you concerned about the unbounded nature? or needing to reduce them?
Not especially. Like,
Okay. All right. Okay. So I'm starting to worry about. We're only 25 minutes in. I'm starting to worry about our ability to get this in on time. But I can see where you're trying to go, right? So you
Yeah.
do code, and it would take a string.
Yep.
I don't remember how that's C++, but and you need to break off pairs and execute swaps as specified.
Start with like the
Whoa.
initialization thing,
What is
set
it?
cards, and autoplay. I'm just copying this from above.
Okay.
And like instead of this loop that it has up here, we want a different loop. Like for I equals I to string dot size over 2. Okay. Then we need to get like the indices for the swap, right?
Tableau will probably be harder with the small numbers at the top. Oh, sorry, I could put this on screen. Tableau will probably be harder with the small numbers on top. Try starting from there.
Yeah, so I think if we should look at if we deal in order with no swaps, I'm kind of hoping it's going to put the aces at the top. But we'll see. We can also just make that. We'll only see what its default is, and if we don't like its default, we can set an initial configuration that puts small numbers on top. The left is going to be something like having to do with string I, and right is going to be something having to do with string I+1. Yep. We want to do this.
I think you want, instead of I++, you want I+2.
Yep. So now we need to do this encoding. So like we need a pause from char.
Sure. Yep. There's very limited highlighting here in this. I would expect it to show functions in a different font or a different color.
If C is greater than A and C is less than equals Z, C minus A. So if C is greater than or equal to capital A and C is equal to capital Z, return C minus A plus 6. I'm gonna write the inverse of the function.
Yeah, I mean we're gonna need it, right?
Probably. We're writing too much Rust.
Oh my god. This would be so much easier in Rust. I wrote professional C++ for like a decade. I really kind of got to like it. But it probably was also the Stockholm Syndrome or whatever the minus 26.
Okay. So now
Is this because that they're discontinuous? There's something between lowercase c and upper A and ANSI? I don't remember the table. Okay.
Yeah, there's like punctuation stuff in between.
And like if we like assert pause less than or equal to 50, greater than equal to 0.
Yeah, we include insert.h for you.
And pause less than 52 because this is 0 indexed.
Yes.
Okay.
Okay.
This also, back in WebKit land, they had a capital assert, which got compiled out. I expect this isn't compiled out.
That's fine. It was only during the setup phase. Okay, so now we need to wire this up to the command line so that we can feed these things in on the command line.
Do we have the ability to write tests?
Yeah, there's a node test.cc. Should we write some tests?
Oh, just for my sanity, that we can round trip in these things before we
go for it.
cover that. I don't know how to run the tests. Whoa.
It's extremely simple. You just type make and then you just run the program.
There's this though. Okay, so this is void test encoding. Right.
So you want to say like pause. What do you call these things?
That's why I went to go copy them.
Yeah. F.
Can we assert? We probably can't assert that it asserts, but that's fine.
It's a very, very primitive test framework.
Yep.
Yeah,
I don't
know. It's something called R.
I see. One of them has get in the name and the other one doesn't. That's why. Is that style? I don't know. I'm removing the get.
Okay.
Gotta polish our ivory tower here, man. It shine. I think we want to go the other way real quick too, and then be done. Right, so this should be pause from care. Right, and there should be. Right, let's be 0 goes to 0, and 51 goes to 51.
Okay.
And you said we need to add test encoding here. And just for our sanity, just to see it fail, do, right?
Okay, that's legit.
Okay. And you say, what do we have to do? Whoa, shell doesn't go up. Doesn't have a history.
Go into the solver directory and type make.
I need a fancier shell. Whoa, what do we do? Not declared in the scope. Oh.
Yes, we do read live chat. Hi. Welcome.
And we even answer questions too when questions are asked.
It got mad. Oh, in our actual code, we didn't get rid of the get.
Named, yeah.
Okay. Fair enough.
What do we do? Come on.
Maybe it didn't save.
Gotta do the compiling dance. Whoa! What did it do? Oh, it tried to run it or something.
Yeah, it failed your test.
Oh, good. Good. Sanity has been restored.
This is an important science control. Do we understand the test suite?
I see when it does make, it automatically runs the test. That's cute.
Apparently. I suspect if we were smarter, we could feed more commands to make and have it do.
All right, deleting file node test. Oh, it does not save on blur here in Replit land. I was recently reading the Replit newsletter or whatever, and I was thinking, I don't think I'm actually their customer. They seem really targeted at students building games and stuff. I don't think they've yet found the professional software developers on YouTube market. Hello, very angry panda or happy panda.
All right, test pass. Okay, so now I think we would wire up a command line argument to that thing.
Well, we also have to do a little bit of plumbing, right? Because if we look at solver, it passes around the seed as the way to do the layout. But yes, we can wire up a right. So we have to go look at options here. I don't know where options is. There it is.
So I was just hoping to get to the point where we'd print out the hand so that we could see that we'd done something sensible.
But this is C++. Okay. Now do you know how to do string argument parsing in this C++ framework?
Sure.
10 points for the winner.
Get opt.
Get opt. String parsing?
Get opt does everything.
Yeah?
It really does everything.
It's the all sing, all dance?
Yeah.
We're like dredging up scars for me.
Get opt. You know, what if? Hear me out.
But what if we just edited the file and didn't try to pass them?
Well, here's my hack. Okay.
Yes.
String.
Hack. Let's hack.
I love get opt. And by that I mean I actually don't like get opt very much.
Cool. So we can just edit solver.
We can do it here. It's fine. What we can just do is we can say just arg if argc is.
It's because we have tattoos.
We're writing in C++ because
And beards.
This is like a starter. We started from an existing C++ solver. We did not.
You also have to understand, we originally had a rule where we would not. You didn't talk about the show outside of the show. You didn't do anything for the show outside of the show. We have eventually learned that you kind of have to violate that if you actually want to have something interesting to talk about. But it's a happy panda. I appreciate you correcting the emotions of the panda. But today I was really busy, and so I did not help with the prep. And Adam graciously did it all in half an hour between dinner and the show. And he found a solver that could compile.
That's my beautiful hack.
And I wish to see your beauty. String swaps.
Okay. I grabbed it out of the RV.
Sure.
You do. We should learn how to use get opt.
No, we shouldn't. We should just write it in Rust. If we had more than 20 minutes remaining.
Actually, you know what? It's this. All right. We can take the hack away. It's this is the syntax. So it's Q. So we're going to say S is going to be swaps, and it's going to go like that. Okay.
Wait, this is not syntax. This is like Perl.
This is how get opt rolls. I actually think this is what it's supposed to be.
I'm glad you have this filed away in your brain.
I did learn about get opt at one point.
I'm sure I did too.
Okay, should we see it? See if it works.
And I let that memory go. So I'm sorry. So you want to print F or count or whatever the heck we're doing here in.
All right, I just want to change this here to be node swaps.
So I don't know what
I
that.
wonder-
Oh, I see. That just shows the layout. Yeah. Okay.
I just want to see if that's going to build and work.
Whoa, what did I do? Make. Okay.
Maybe you mix solver, it might be faster because it'll just make the actual binary we care about.
That would make sense. I don't know if Control C works here. We're also so close. I feel it. Actually, I can't feel it at all. Okay. Let's confirm. Solver's up to date. Okay. Solver.
I did put the aces at the beginning, so that's good. That's good. So its initial setup looks fine. So let's try to give it a swap. Let's try to swap like A and B.
A
Just
and B.
dash S, A and B, yeah. Yeah, swap A and B. Amazing.
That's okay. And then what about A and
Z is too big, right? Capital Z is too big. Try lowercase z.
like blown up? What would be, so 26 plus, we want to get to 51.
Yeah, so try Y. Yeah, capital Y if you want.
It's not going to be.
That was lowercase y. Yeah.
Did it work? What are we swapping with? No, it didn't work. AB works.
Okay, I'll try AY.
Oh, that didn't work. What about AB? Should swap it back. Didn't work. All right, so something's not working in our second.
Maybe our loop is no good.
In our swapperoo.
Oh, I know what's wrong with our swapperoo. Our loop is totally wrong. In node.h.
It's because we didn't write a test.
We did not write a test. It's here. We both divide by 2 and increment by 2. So I think for simplicity, let's just not divide by 2 here.
Oh, I see. Yeah.
Let's do -1 just for sanity's sake.
What? Why is the money? Oh.
Like if there's an odd number, we'll just ignore it.
All right.
We need to make solver. Sure. This is
C. One of 4 times.
This is a non-incremental build. It does not know how to like build the other compilation units.
This is one of the things I really, if I can, I can espouse philosophically about Rust for a moment. Rust just has some very nice, ignoring the language, just the whole crate, not the crate system, the like Rust updater thing. What the heck is it called? Cargo? No, that's Cargo. The package manager.
Yeah, it just forces you to have a certain. Oh, Rust up.
Mm-hmm. Rust up. The tool chain management. It's just like it is from this decade, which most other tool chain management is not from this decade. Okay. Okay. So we do need do a little bit more plumbing.
Okay, to try to actually make the solver work.
Yeah, because it passes around this seed thing. We basically have to get rid of all the places that it does seed and replace it with our.
Is that really true?
The beams need to hold on to.
What is options? See, I see, because the beam constructs its own copy.
Mm-hmm. Because it's on its own thread.
I see. So we should patch in swaps here instead of seed.
I mean, I guess we could pass it in layout, but I don't know what the layout does. Is the layout immutable?
What does the beam do with the seed? Maybe that's what we should look at. It remembers it. And what does it do with it?
Next.
Prints it out.
Is that it?
Okay.
Well, that's silly. Why
okay.
do we care about the beam printing the seed?
So I uncommented the return 0. You want to try running it now and see if it can actually solve the like ace 2, 3, 4, 5, 6 layout.
All right. So what we're saying is that the seed in the beam doesn't matter.
I don't think it matters.
Well, how does the beam get which layout it's solving?
I believe it passes it on line 370, 357.
357 fine. Okay. Great. I wonder why the layout doesn't remember its seed number, but okay. I guess that makes sense. That those are separate. All right, so we actually don't want to pass any S, right?
Oh, that's fine. I don't think it really matters.
But this should be unsolvable.
Oh, you think this is unsolvable? I bet it's solvable. Well, maybe not.
How would it be solvable? You'd throw all 4 kings up onto your 4 empty squares, and then you're just done. You're like, you have no place to put them.
I feel like I've dealt this before and solved it. Because you end up putting the queens. Like, it's not that hard, right? You put the queens on the kings, and then you...
Oh, I see.
You just have to go up, like, the...
Yeah, you have to do some of the...
Yeah, so it's
it
solvable.
Seems to think it's solvable. Okay.
Okay, so now I feel like what I want to do is I want to make this tool just print out a number, which is the hardness of the board, like the number of moves. And then I feel like I want to wrap this whole thing in Python or some other language to actually do the the next phase of the search.
I just remembering that you were grumping over chat about how you were you had wrangled the Perl, and then we're now fighting the Python or something.
That was someone else's Freecell solver. I was just trying to build it, and it spent an hour just like trying to install Perl modules. I just gave up. This one was way easier to work with.
Okay. Well, they did. They wrote some nice make files. All right, so you just want to print out the hardness, which you said is like the number of moves it takes to solve?
Yeah, so here in prefix search, once it's found the coded solution, I just want to print out... I guess it doesn't really matter, just a measure of the hardness, right? So I just want to change this print statement. I don't know if you can see what I'm looking at here. I'm on line 313 of this file.
I'm sure there must be some way for me to follow you, but yeah.
I just want to replace this with...
what's with the beam IDs? Oh, I see. That's only the first one prints. Makes sense.
Print out the length, basically.
Oh, just at the end?
Yeah. And then I want to turn off these other print statements because I don't want them to distract from what we're doing.
All right. Yeah, this all makes total sense.
I'm going to turn off the thing that shows the layout.
Quiet mode or something.
Yeah.
We can pass -Q or something. But yeah.
I just commented out the other print statements.
Okay. All right, so we think...
I think we run this... Oop.
Whoa.
LD. Okay, fine. It's a long number. You may need to control C.
The warning.
No, just a warning.
Oh, somehow...
this is no good. There's still some printing going on. I found it. Here's progress. Let's get rid of that.
I see. We could also just pass the progress, but yeah. Or pass the quiet, but that's fine.
Oh, okay. Max level sign.
We can brute force it.
Just don't do this.
Oh, you don't want any of that, do you? And not quiet? Like, what's this doing?
It's where this max level size is.
I have no idea, but if it's only updating it when it's not quiet, that feels like there may be a bug in the program.
It's only ever used here. Okay. Try now.
On it. I was marveling this week. Dion commented on the show, but he replied to the Twitter thread from the Twitter posting. and I was just marveling at the importance in software and just in life of making something just marginally easier.
Mhm.
That I wonder what sort of people I'm not trying to reach lots of people with the show, but just like I wonder what that differential is by just making the video available directly in someone's feed. Fewer clicks, fewer things to remember. What that changes for people.
I mean, just applied to this project, like the barrier to entry to use this code base versus the other, which is vastly different. Like it was 30 seconds to clone this repo and type make.
All right, so we're still missing a printf. This one,
Okay.
max level size.
All right, take that.
UID.
We might want to just search for options quiet, since they all seem to be labeled quiet.
Or we can just pass options quiet.
How does it work?
I think that's all of them.
Okay. Then I printed out 188, which seems like a sensible number.
I'm impressed at how far we've gotten.
I mean, I think it's a fairly simple Python script and then a lot of compute away from doing this. There's a question of like how many swaps you want to do at a time. Like, so it would be like a hill climbing algorithm, right? So there's going to be a question of like how far you want to jump. And like we probably want like a cooling thing where you start off by jumping far away. And then as the algorithm goes on, you make fewer swaps at a time and sort of explore closer and closer.
Well, you're going to end up with load-bearing swaps, though, right? Where like it's just the one swap that causes the problem. So you actually have, I think, sizable targets to hit. And so it's less, I think it's less that you need to like adjust down. But you're right, it might thrash around like if you're jumping between too many.
We have 8 minutes. Should we take a swing at this Python file?
Yeah.
Or do we want to save that for next episode?
I think either way, I also would caution that because we're passing things through the command line, we're going to be very limited with the number of swaps we can make. I don't remember how long command lines can be on Linux. They actually probably can be really long on Linux. It's Windows that has crazy short command lines.
We may eventually need to make a swap optimizer that says, "Oh, these swaps are all redundant." Collapse it down.
Or you can pass it through. You can pass it through standard in, and then you're not limited.
That's true. I mean, also like you're not going to have to make that many swaps. Like by the time you made 52 swaps, you could have created any board possible.
Okay, so we just write Python.
Yeah.
We're going to talk about pizza for 5 minutes. Let's try some Python here. Python.
I don't think we're going to like get a fully working Python file, but I think we could like just make a thing that calls out to the compiled program, reads in the number, and does something with it.
Oh man, I'm gonna make remember Python now too. Was it like the sub process?
Yeah, sub process checked call, I think is the one we want.
And you want solver. So we think that Python.
We're going to want to make like a function, right? That's like.
I'm just trying to see if I remember how. What select one to run?
I think you get to make a like array here. If I remember correctly.
I don't know which Python we want. Maybe we want Python 3.8 out. Do I want full? Right. Add Python 3.8 to this replit. Okay.
Sure.
I'm looking for the Nix file.
Say show hidden files with the 3 dots.
3 dots. Show hidden file. There we go. Replit Nix. Okay, and we want.
I think you say
packages.
Yeah. pkgs dot python 3.8. Yep.
Okay. Then do I have to like click a rebuild button or something?
If you just hit enter in the shell, it'll. Yep.
It's kind of cool.
But it moved. It lost your current working directory, which I was really annoying while I was.
Oh, where you're trying to get the darn thing working.
I'm not sure what this comment means.
That was a response.
Oh, that was a while ago.
Much earlier conversation. Okay, so Python swap.
Oh, more closing parentheses, please. Right. Gotcha.
What did it do? Oh, this is a funny shell behavior that when you click on one of these, it opens it. I mean, makes some sense, but
okay.
What's up? Subprocess has no check to call. Subprocess 2 or something like that.
But it's call. Check call.
Looking it up. Guess you're looking it up too. Run.
Call.
Oh, call. Okay. No such file or directory.
There's no such file or directory solver.
Seems to do it.
It's doing a thing.
Thing with the stuff in the place. Another idea. Put all the
red's low.
Red's low.
Yeah, I mean, I think we're not going to find it by manually tweaking it. We're going to find it by having the computer bang its head against the problem for a while.
Computers are very good at that, even if they don't actually have heads. Now, why is it hanging out forever? That seems odd.
I think it's.
Oh, okay.
Yeah, 190. There you go. Legit.
It worked. Okay. So,
okay. I think we should stop here. Yeah, but I think the next step in this project is to basically use this harness in Python to start exploring the space of swaps and try to make make number go up, make line go up.
Need to print what's called progress. Need a way to generate swap strings. Need a way to explore, like this is, I'm repeating myself, but explore from a swap string to a new one. And then are we just like randomly walking?
Yeah, I think we just randomly pick I think the basic version would be just randomly pick two things to swap, append it to the current swap string, check whether it makes number go up. If so, great, that's our new base. If not, try again.
Mm-hmm.
And then iterative refinements on that idea to actually climb the hill efficiently.
All right. Well, I think honestly, I think we got way further than I was expecting tonight.
Yeah, I think in another episode we'll actually have something maybe.
Yeah, I think we got. I mean, basically, the next episode is hill climbing, right? Because that's you're just exploring hill climbing algorithms with a relatively slow climber. And
a sort of like complex space that you're navigating in, right? The complex space of like swapping one card on the board and what effect does that have on the game is complicated.
Yeah, this is cool. Anything else you want to say? How was the pizza this week? We did not make pizza this week.
No, pizza's next week. We just put it on the calendar.
Or maybe we did. We made pizza recently, and we did the whole shebang. We made the fancy sauce. We made the fancy bread. It was really good.
Did it work? Did you followed all the?
Oh no!
You spun around 3 times and tapped your head.
There's so much. The pizza pope has way too much religion, and like the individual's recipe is like, take all these things and do the water at exactly this temperature in this amount first, and then I just took all the ingredients, I threw them on a mixer, and I turned them on, and I pulled it out. I mean, I've made hundreds of loaves of bread at this point.
We got the little temperature scale that puts in the water and it measures the tip and gives you down to the 10th of the degree centigrade.
I don't think any of it matters.
I can't imagine
for the bread part. And yeah, and then what actually made the pizza work this week was that it was just too much mental burden for me to do the whole thing, and so I split duties. My wife handled all the toppings, and I handled all the bottomings, and it worked great.
Together, you had pizza.
Together, we made pizza. Anyways, this was fun as always. It was great to see folks, and yeah, come back. Happy to chat in terms of come. We always are happy to answer comments, and I will see you next week, Dr. Barth.
Yeah, see you next week.